So in our last explainer, we got a handle on variables, how to declare them and how scope works. But that leaves a pretty big question hanging, right? What kind of data can those variables actually hold? Well, today we're diving into the absolute fundamentals of JavaScript, the primitive data types.
Here's our game plan. We're going to start with what a primitive type even is, then jump into the stuff you'll see every day, like strings and Booleans. After that, we'll get into numbers, both big and small, and untangle the whole null versus undefined mess. We'll finish up with the unique symbol type, and finally, how to check what type of data you're even working with. Okay, let's get into it.
All right, so let's talk about what's actually going on inside those variables we've been creating this whole time.
You know that a variable is kind of like a box, a container. But in JavaScript, the language is super flexible about what you put in that box and when. And that flexibility points to a really core concept of the language. See, JavaScript is what we call a dynamically and weakly typed language. Dynamic just means you don't have to decide a variable's type ahead of time. It gets figured out on the fly as the code runs. And weak means the language will try to be helpful and automatically convert types for you. Now that can be convenient, but trust me, it can also lead to some really weird bugs. And that's exactly why understanding these types is so important. I think the best way to wrap your head around primitive types is to think of them as the atoms of JavaScript. They're the smallest, most basic pieces of data you can have. Everything else, all the complicated stuff you're going to build, is made up of these atoms. And here's the key. They are immutable. You can't change them.
And here they are, these 7 primitive types in all their glory. We've got number, BigInt, string, Boolean, undefined, null, and symbol. That's it. If it's not one of these 7 things, then it's an object, which is a whole other story we'll get to in the next explainer.
So let's start with a couple of the most common types you're going to be working with. We've got string for all our text and Boolean, which is just the simple logic of true or false that powers, well, pretty much every decision your code makes. So a string is pretty simple, right? It's just a sequence of characters, some text. But its most critical feature, the one you have to remember, is that it's immutable. Once you create a string, that original string can never, ever be changed.
Now check this out, because this is where people get tripped up. We create a variable name and set it to Allie. Then we try to change just the first character to a lowercase a. You'd think that would work, but because strings are immutable, it just doesn't. It fails silently. When we log it out, name is still Allie. Anytime you use a method that looks like it's changing a string, like uppercase A, it's actually creating a brand new string in memory and giving that back to you. The original is untouched.
Okay, let's switch gears and talk about how JavaScript handles numbers. And this is actually a pretty cool story about a problem and the really clever solution that came along to fix it. You see, in JavaScript, every number is stored in a special format that gives us a huge range to work with. But there's a limit. There's a maximum integer that we can represent with perfect, guaranteed precision. And that limit is this huge number you see on the screen, known as number.maxSafeInteger.
So what happens if we try to do math past that point? Well, things get weird. This line of code really shows the problem perfectly. If you take the maxSafeInteger and add 1, you get the exact same result as adding 2. The language can't tell the difference anymore. The precision is gone, and our math is just plain wrong. And you can imagine this was a huge issue for things like finance or scientific calculations. To solve this, JavaScript introduced BigInt. It's a totally separate numeric type built for one thing, handling integers of any size you can imagine. And creating one is super easy. You just stick an n on the end of a number.
So, what's the bottom line here? Number has a limit, BigInt doesn't, practically speaking. But the most important thing, the real takeaway from this slide, is that you absolutely cannot mix them together in math operations. If you try to add a number and a BigInt, JavaScript will throw an error. You have to be explicit and convert one to the other first. Okay, this next part. This is one of the most common points of confusion for anyone learning JavaScript. Both null and undefined seem to mean nothing, but they represent emptiness in very, very different ways. Let's just break this down. Think of undefined as the system's default. It's what JavaScript automatically assigns to a variable that you've declared but haven't given a value to yet. It means a value just hasn't been provided. Null, on the other hand, is something you, the developer, have to assign. It means I am deliberately setting this variable to have no value. It's the system saying, I don't know, versus you saying, I know, and the answer is nothing.
For example, if a user deletes their profile picture, you might set the profile picture URL to null to show it's now intentionally empty. All right, now for the most unusual primitive type, the symbol. Its whole reason for existence is to let us create property keys for objects that are guaranteed to be unique. To really get symbols, you have to understand the problem they're made to fix. Imagine you're writing a library, and you need to add some secret internal data to an object that a user passes into your code. If you just use a regular string for your property key, like __admin, you're creating a potential problem. What if some other piece of code, or even the user's own code, decides to use a property with that exact same name? You'd have a collision, and one of you would overwrite the other's data.
And here is the elegant solution. When we use a symbol as our key, it creates a completely unique identifier. Notice what happens when we try to list the object's keys now. Our special admin key property is gone. It's hidden from the normal ways you'd inspect an object. Since every symbol is unique, even if another library creates a symbol admin, it won't be the same as ours. No more collisions. It's like a secret key for our object. So if symbols are kind of hidden from view, how do you actually find them again? Well, like this slide shows, they're invisible to common things like foreign loops, object keys, and they get completely ignored when you turn an object into JSON. To get to them, you need a special tool for the job, object.getOwnPropertySymbols. This makes them perfect for attaching that metadata without getting in the way of normal code.
Okay, we've officially met all 7 atoms. Now, how do we figure out which one we're dealing with in our code at any given moment? Our main tool for this is the type of operator. For the most part, it does exactly what you'd expect. It gives you back a string with the name of the type. But there is one famous historical quirk that you just have to memorize. For null, typo returns object. This was a bug in the very first version of JavaScript that they can't fix now without breaking half the internet. So just remember, to check for null, you always have to do a strict equality check, like variable equals null.
So to wrap it all up, these 7 primitives are the immutable fundamental atoms of JavaScript. They each represent a single simple value. But the real magic, the real power of the language, happens when we start combining these atoms to build more complex structures. And that brings us perfectly to the next step on our roadmap. In our next explainer, we are going to dive deep into JavaScript's only complex data type, the object. We'll see how these atoms combine to form the molecules that build absolutely everything else, from simple lists of data to powerful functions. This is Developer Roadmaps. Map your path, build your career.